once again to lecture. I have a lot of slides, and so I hope I can get through in the limited time, but let's see how far we can go. So as Professor Noor already mentioned, I'm an electrical engineer. Actually, since a few months, I'm working on the African continent. I'm physically at the moment in Germany, but I have an assignment besides of my work in Heilbronn to a new German university in Cairo, and so I'm very happy to do this. Okay, let's just start. And by the way, if you see my video stream, which I now switch off because of the bandwidth, but you see me in Johannesburg, and I'm really regretting that this is not possible at the moment. You see the jacaranda trees in the background, and yeah, due to which I'm not able to see you personally. Last year I could be there, and so the picture in the background was taken last year. Okay, I'll switch it off now. What is IoT and COVID-19? That was my first question when we discussed the subject of this lecture, because this lecture is a very technical one. I'm an engineer, so I want to talk too much about, let's say, politics or social things, but I'm not an expert in that. But I think when I was running through my slides, I was thinking that IoT has a lot of, let's say, COVID-19 has a lot to IoT and vice. And just to make it short, there are several developments, especially here in Germany, that may support. Now there are several developments on COVID that could be faced with IT and Internet of Things, and vice versa, the developments in IoT, which could help to cope with pandemics, not only COVID-19. I think this will not be the only one. And I just picked 4 important points. This is one thing is the changing way of people's ways to communicate, to collaborate, and to socialize. This has become a tremendous change in the several months. And one of the indicators is the way I'm giving this lecture today instead of being with you. But also, when you watch the news, especially in the last days, we find a huge reconsideration of, on one side, of individual responsibility, community responsibility, and also governmental responsibility for the health and the safety of people. And there are many discussions at the moment why we in Germany by now are running quite well through the pandemic. And I think this is it has to do with the individual behavior of people who were very anxious in the beginning of the pandemic, stayed at home and didn't go out. And we had this feeling we have to do something. Nowadays, it's getting looser and looser, and I'm very curious what will go on in the next few weeks, even because it's getting cold here now. Then we have changing of mobility, of course, not only e-mobility or whatever. It's the question, how often do we drive and move, and where do we drive and move? And this has changed in the last few months. And of course, we all understand that we have a tremendous need of tracking, confining, and fighting this pandemic. So how can IoT help? I would say we shouldn't put anything under IoT here. IT can help a lot with networks communication, as we see now. Also mobility optimization, and IoT itself is a very small subset of this, of the whole. Yeah. But IoT can help us a lot with mobility, finding things, tracking, surveillance, and so on, and also confining outbreaks. And I will give you a few examples, and then I move over to the technical part. Let me see. Okay, I was thinking, how could a university contribute? And I found a very nice idea. It's not mine, but I was excited about it. It's very easy, for instance, to build small, and IoT always means small, to build small devices to measure the air quality in a room. Normally, these air quality sensors measure carbon, hydrogen, or carbon dioxide, and they are extremely cheap nowadays, like a few dollars. With a small Arduino, for instance, and maybe a LoRaWAN shield, plus the free Things network, it could be possible to survey the CO2 concentration in school classes, in classrooms, in schools. And for not more than about $20, it's possible to make a make a surveillance of the CO2. And of course, CO2 is connected with human breathing. And at the end, you can say how many people are breathing in a closed room, and this should be avoided, because besides of the CO2, they may also exhale the viruses, and rising CO2 concentration could help to indicate that there is a need of opening the windows. This is IoT at its nicest. Or there are small cameras with considerable resolution, which can be connected to a very small processor, like in this case a Raspberry Pi, which are installed in crowds, in places where people tend to gather, and can check the temperature, the body temperature of people. So these infrared cameras are very much affordable, and they can help, for instance, in stadiums or in airports or in train stations to identify people with fever, and to give let's say, maybe a statistical support in confining the spreading of virus. And of course, there are a lot of new sensors on the market for individual healthcare, like heart rate variability, blood pressure, the lung functions, motion itself, respiration, and so on and so on. And these are they are so small nowadays that they can be weared in the clothes, or in bracelets, or in watches. But also IoT is very important when it comes to, let's say, saving the mobility, restricting, or let's say saving miles, as I put it on the headline, and just limiting the need for mobility. For instance, there are a lot of monitoring devices. I give you 2 examples. We have this big container vessel here, and all the containers are owned by certain companies, people, and people like to know about their freight. Yeah. Like if it's maybe a deep freezing container, they should be it should be clear and obvious that the deep freezer is running. Or if you carry batteries for electric cars, for instance, if they are healthy or if they tend to maybe explode in the worst case. Many containers or many payloads are shouldn't be shaken or tilted during the transport, and also this can also be monitored. And even the ship itself can be monitored, or even, and this is a trend nowadays, remote controlled. Another example, if you look at these power stations, then of course we need people to monitor them, but they shouldn't necessarily go out to the station. They can do it from home or from home office even, and this is done by the help of IoT. When we talk about IoT, and now let's go a little bit deeper into the technical part, then we have to consider the complexity. The Internet of Things is mainly something which copes with low complexity level. And just to give you examples of different levels of complexity, I mentioned temperature, which is one value, very simple measurement principle, and you can send it over a very low power and low data rate network. Also, acceleration sensors, for instance. In this case, the measuring system, the sensor is much integrated to a very small size. Much more complexity is given by navigation satellite systems. The data itself is not so. The data is a complex network of satellites and stations. And the complexity of a camera, of a surveillance camera, for instance, it comes from, in this case, from the data and not so much from the sensor. So what is the challenge? I was talking about low complexity. So if we talk about IoT, we always talk about masses of sensors and network nodes, millions. For instance, if you put a network of different quality sensors over a city or even over a country. So we have millions of sensors. We repeat things, and that's always a question of cost. And the next thing, these sensors or these nodes are normally have normally no access to the power grid. So they need they need a battery to operate, and so or temperature differences, solar power, or even by shaking. And this is only a little amount of energy that can be provided, and power consumption is one of the big challenges of IoT. User interface, which may or may not be there, or may be available through the network. Then the calibration, if we are talking about thousands or millions of devices, we have to calibrate them to make the results comparable. Also, the development cycle time is very short. The environment may be rough. in terms of temperature, pressure, humidity, dust, and whatever. Computing power is therefore, and for the above reasons, limited. So we have small code sizes. We have to code efficiently. And also for the above reasons, we have very limited network capability. So on the contrary, we have the internet with computers as nodes, but the nodes in an IoT network are much more restricted. A few bytes of data, maybe a few kilobytes of code, and we are talking about microamps for power consumption at regular voltage levels like 3.3 or 5 volts. And this is something we have to take into consideration. And now I'm running through the slides, but Precious has the slides also, so you can ask for having the slides later on. I'm just running through the next slides about the sensors which are nowadays available. These are the environmental sensors, which cost just a few dollars nowadays, and they are affordable and accessible by a lot of people nowadays. And then we have biometric sensors, which more and more intrude also the human body, and they became much, let's say, more popular now through COVID, especially the protein sensors, which are used for this quick tests, where you bind antibodies to viruses if they are there, and these antibodies are marked and can be checked by a small electronic sensor. It's called an ELISA test, and not to mess with the PCR, which is much more complex. But I'm talking about these home tests. Also, the breathing gases, body temperature, all the electric things like electrocardiogram, electromyogram, electrodermal activities, and so on. And of course, the electrical measurements, as you know, force and momentum sensors extremely important when it comes to remote handling, robots, and so on. It's basically the same as our body does. It measures the forces in the muscles, and in order to close a control loop. Proximity and position sensors, and you see the complexity is increasing now. Very often widely used in automotive nowadays. It's the same with the inertial and motion sensors in aerospace and automotive. And the sensors became very small nowadays. And finally, one of the, let's say, the crown is the global navigation satellite systems, which is known to many people as GPS, but GPS is the US military GNSS, but we have so many nowadays. In Europe, we have the Galileo system, in Russia, the GLONASS, the Chinese have one, the Japanese have one, and so on. Unfortunately, we cannot talk about this more into details. And at the end, last but not least, imaging sensors, which became extremely cheap nowadays. You get for a handful of bucks, you get depth camera, and combined with infrared or combined with normal color cameras, for instance, the Xbox or the Intel RealSense, which is very much affordable nowadays. Okay, so let's talk a little bit about IoT networks, because this is, let's say, the crucial thing. If we have also the sensor data, we know about the complexity of the data, and then we need to talk about how to convey the data to our IoT network, and later on, of course, how to evaluate the results. Yeah. And therefore, we need, of course, small devices, microcontrollers. You can see a very tiny one, 80 tiny, which is from Microchip, only 6 pins. Yeah, it's just sufficient for power, ground, plus one sensor, plus a serial output. That's it. And with this tiny microcontrollers, we have a bunch of different bus systems. You should, let me see if I can turn on my marker, but that's obviously at the moment it's not possible. Ah, now it's working. Yeah, marker. So of course we need this connection from the sensor to the microcontroller, and from the microcontroller to the transceiver. And for many, there are many sensors on the market, or sensor modules, or system on chip modules, where the sensors and the controller and the transceiver are integrated. But also nowadays we have a lot of small bus systems, which are not much complex, not much expensive, and available to these controllers. And secondly, or let's give you another example, and this is the automotive networks. Nowadays, the last let's say 30 years, the number of devices in cars, let's say control units in cars, increased tremendously. So in a modern car, we have reached about 100 different controllers, and this is one of the things I'm teaching in our university. And this has reached the top at the moment, and the architectures will change in the future. But here are a few examples of very small buses for single sensors, for instance, and of course the high complex data transmission via Ethernet. So this is Audi S5. It's produced just 20 kilometers from the place where I'm sitting now. And you can see this complexity of the control units. And this has, as I mentioned, reached a limit nowadays. So at the moment, we are trying to centralize computing power in order to reduce the amount of devices and the complexity of the overall systems, but also just because the big higher computing power at an affordable price is now available. This was not the case in the beginning of this development, where we had a lot of small ECUs. And when it comes to integration, and this is something I would like to emphasize, because it's part of the IoT idea, is that we end up in a few years with the cars being part of a big cloud and a community of other cars and systems, which may help to increase safety by early warnings by remote controlling the car. I just keep these slides because we unfortunately we lack of time, and I don't want to bore you with the technical details, but I just want to mention that even in the small, low complex bus systems, the development has not ended with UART SPI and I2C, which are very popular bus systems, but they may not be suitable to any environment. This is something we often forget as university teachers or students, that things that run on the table, on the lab table, do not necessarily work in the real environment. And together with my student, I often paid the price for saying, oh, it's running, our prototype is good, and so on. And then we integrated it in a car, and then it was never running at all, because the power of the battery voltage level is changing all the time, the temperatures, the vibrations, the dust, and everything. These are conditions that change a lot, also in the functionality. And so there is an ongoing process in developing very small networks and low complexity networks, which are reliable under any bad conditions. For instance, this one-wire network or the PSI-5 network, where you can just cascade a lot of sensors with one ECU. And by the way, all of these slides have a reference, so you can, if you are interested, you can go on and do your own research on these topics. Now let's talk about wireless sensor networks, because wireless is a very crucial notion in IoT. As I mentioned, we have millions of remotely distributed sensors in maybe surveillance networks, and there is no chance to reach them or to access them via wires and cables. So we should talk about a cheap, low complex way of connecting sensors, actuators in a wireless network with low power consumption. And there is a standard which is called RFC 7228, which talks about a classification scheme in the internet. Recommend you, if you are interested in that, to run through this standard. It's available on public domain. Just Google RFC 7228. And this gives, let's say, taxonomy and of nodes and networks. And I just want to emphasize two ideas of this standard. This is the idea of a constrained node, as I mentioned in the very beginning of this talk, and also of the constrained network. A network should be cheap or even free. It shouldn't consume too much power. It should meet the regulations on frequencies. It should be able to share the channel with a lot of nodes. And a big thing is the TCP/IP protocol, which is very well known, is not suitable for all these things because it's too complex and requires too much computing intelligence. We have, for instance, limited bandwidth, only small signal packet sizes. We need data compression, and we have only a limited availability of frequencies which are shared by many devices. We call them ISM bands. In Germany, in Europe, it's the 432.3 megahertz, 868 megahertz, and the 2.4 gigahertz and 5 gigahertz networks, which you know from your Wi-Fi routers because they are also member of these ISM bands. Also, all the remote controls for door openers and whatever. I'm just running through the standards because we are running out of time. Bluetooth, Zigbee is very popular nowadays in smart home. DECT is it's the old lady, introduced at least 25 years ago. And GSM for remote access, of course, or nowadays it's LTE, but this is rather power consuming, but even with a very high bandwidth. Wi-Fi, of course, and RFID, which doesn't require any inside battery or power supply, and which is very popular nowadays in the tracking of goods, for instance, in trading and also in the production. And I want to end up my lecture with LoRaWAN, because I find this very interesting also for the work with students and for doing even in sparsely settled regions, for doing monitoring. It's the big advantage of this LoRaWAN is that it's mainly free. We need only these chips for a few euros or dollars, and it can overcome far distances. So we're talking about kilometers, not about hundreds of meters like in the 5G or LTE networks, where you need a very dense grid. But it's very much limited. But for monitoring of devices, it's even handsome and feasible. And there's a community project with free access. It's called the Things Network. And with the same technology, commercial networks like Sigfox, where companies pay a few dollars once, and then they have lifelong access, or their devices have lifelong access with a few bytes per day, but which may be sufficient for tracking. When we talk about IoT network architectures, we often talk about this broker architecture, where a lot of public publishing nodes like sensors send their data on a regular basis, and a distributed amount of subscribers just take the data if they need them. You can find this architecture, a little bit refined in smart home applications. Nowadays, smart home applications differ very much in technology. So we use Zigbee or DECT or Bluetooth and other technologies for the nodes. And there is one gateway. This is an important word that concentrates all the information from the different networks and sends them to a controller. And this controller realizes the functionality, and then via internet access on cloud services, the users can access their home, for instance, by their mobiles. So let me just say a few words about LoRaWAN, because I think this is a very nice also example for using in the university projects, because everything is cheap and even freely available. Here you can see an older map. This is not this moment, this was actually last year, but let me show you some ideas of LoRaWAN. For instance, you can use it for tracking of cattle, for irrigation monitoring, for parking monitoring. And of course, there are hundreds of ideas which come up in a few seconds if you consider that. LoRaWAN has an architecture which I just want to introduce to you. We have these LoRaWAN devices. These are small sensors. For instance, at the very beginning of this talk, I showed you the air quality measurement, and these devices send data via a gateway to a router, and the router creates a data package which is sent to the broker, distributes the information to all the subscribers, and they run their applications then. Unfortunately, this limited time doesn't give me the opportunity to explain more, but you can see it. Then we have the Things network. The Things network is a community network where you can access your data. And in this network, all the concentrators, all the stations, which I show you here, for instance, connect together. So no matter where your nodes are distributed, they will find concentrator somewhere. And even you can see I put two maps together. This was Johannesburg 2019, and this is Johannesburg 2020. And you can see that the number of routers has increased. And we see, this is a nice detail, we see two cities in common between Heilbronn. Heilbronn is here. Between Heilbronn and Johannesburg is, you can see it here, Heidelberg, South Africa, and Heidelberg, Germany, very close. The nodes can be held very small. This is everything. You need a small processor for €1 or so, and this LoRaWAN module, and this is sufficient together with a sensor to run your own node. And the data then is distributed in the MQTT protocol, which is JSON based. So for instance, we can describe a sensor by this syntax, and you can easily follow the idea that this is very easy to read by a computer. I just give you an example which I did with my students. We have a small device here with one microcontroller. You don't even need this display. And then with a sensor board, which I show you here, this is an air quality fine dust sensor. And of course, we have to send it with this LoRaWAN module. And then there's a concentrator in our school available. And so we can set up a network of these fine dust sensors. Okay, that's it. Very quick and very brief. I hope there were some interesting things for you to reconsider, and I would be happy if you had any questions and wanted to start a discussion. Thank you very much.
Thank you very much, Prof. Ansgar Meroth. That was really a brilliant presentation, very informative and very topical and useful. Now,
thank you.
Thank you very much anyway. And we have already recorded this, so we'll put it on our website, and Precious probably will do the rest in publicizing for those who couldn't attend it today, to this wonderful presentation. Now, I put this to the floor now. Is there any question that anybody has got for Prof. Ansgar Meroth? You can raise your hand. I may be able to see it. If not, Precious will let me know. There must be somebody. Some brilliant questions. No? Okay, simple question. Yes, we have got Onatu George. Could you please unmute yourself and then ask the question?
Thank you so much, and thank Professor Meroth for this very useful presentation. Onatu George from Urban and Regional Planning Department. My question is that could you please be able to share with us with respect to what are the critical issues which you feel the government should reconsider, most especially in terms of responsibility, with regards to borrowing from German experience? What is it that we feel we can be able to share? Then the second one is equally to request on behalf of our department, which I don't know whether my HOD is actually in this particular presentation. We would like to engage with you, especially on issues of LoRaWAN with regards to, because in our department we carry out a lot of research with respect to issues of speed train, on issues of rapid transport system. So your presentation actually talked to us a lot, and we feel that there is a lot of commonalities, and we equally would like to extend this particular presentation to more amicable relationship as well as network, even if it has to be in the areas of signing an MOU or memorandum of engagement with you. Thank you so much for the presentation. It's useful to us.
Before Prof. Ansgar Meroth answers that question, Onatu, we already have got a memorandum of understanding with Helmholtz University. So, and in fact, it has been going on for quite a few years. Thank you.
Okay.
Now, Prof. Ansgar. Prof. Ansgar, somehow we cannot hear you. You might have to unmute yourself.
Yeah, sorry, maybe. Okay.
Yeah. Now I think we can hear you.
Now, so these are challenging questions. First of all, I'm not an expert in disease control. And it was actually, we had a hard time in March. I was traveling in February. I was in Cairo, and I came back with a horrible cold, and then I traveled again to Africa in March. And when I returned, I really dropped into the lockdown here, and the lockdown was. It was extreme. I mean, you could buy food and you could buy some necessary things for the house and garden so the animals wouldn't die or so. But then nothing worked. Nothing. It was the cities were completely devastated. Like, no, not devastated, but empty. You know, you couldn't see anybody on the street. It was like people had fled. You know, nobody was there, and there was a very high amount of awareness in the first weeks. So people really never touched each other. We used tons of alcohol for disinfection, and then wearing mask is a very big thing here. And of course, we have people who are against it and protesting, and the number of parties is increasing. But if I ask people if I ask my friends, they are very aware of this pandemic, and so this is one thing. This individual responsibility, or the let's say willing of people to contribute. This has changed. I think it has changed worldwide, but I think it's crucial. And yeah, I cannot say much about politics, but obviously those leaders who denied the responsibility had more problems than others who took the responsibility. I think you can see it worldwide in the countries. So, but I'm not an expert in politics. I'm just reading the news. Coming to the technical issues, I would say yes. I am. Especially LoRaWAN is something that is very suitable for research. I have to admit that I'm very much at the beginning. There are more experts, but I think the MOU we have together, two universities, we should be able, especially when the pandemic is over and we are ready to travel, we should try to establish maybe a master project with students. We could also initiate shared master projects where one student in Johannesburg and one student, or let's say a couple of students in Johannesburg and a couple of students in Heilbronn collaborate for one project. This would be nice. Next semester, unfortunately, our semester has already started and all the projects are out. But in the upcoming semester, it could be an interesting issue. And of course, I'm very eager when the pandemic is over and the traveling restrictions are over. We welcome your students, and we try to get these scholarships again. To help your students to come here and do research on that topic. So I'm very open to that.
Okay, Prof, thank you so much.
Thank you very much for that question, Mato. Yes, that MOU that we have got with Helmond University actually covers not only Phoebe, but the whole university. So I think once this pandemic is over, we'll probably try to see what else we can do. Now, is there any further questions? Technical questions. Can I see somebody's raising hand? No, not yet.
Maybe I comment something on the time.
Okay.
We are now establishing. We want to file a proposal in the German academic exchange agency to establish a virtual research collaboration on, let's say, postgraduate master level. And I think this could be an interesting example project when we find 2 or 3 students, master students on our side, and 2 or 3 master students on your side, to create a project in IoT.
Thank you very much for that suggestion. I see Dr. Madushele Nakasuni, he had accepted the invitation to join, but he has not joined in. He's also looking forward to a similar sort of idea about virtual sort of learning, etc. in the at the postgraduate level. You probably will remember him because last time when you visited UJ, I actually sent him to the airport to greet you. Do you remember that person? Yeah, he's the person. So I'll probably pass on this information to him so that he can also contact you, and others who are already here may also think, what else we can do. Let's get over this pandemic first, and hopefully everything will be normal.
Yeah, now, let's cross the fingers or whatever, pray. Yeah.
Anybody else? Any questions? Come on, don't be shy. Just Tebebo.
No question from my side, Prof. Thank you.
So you understood everything, right?
I will go through the slides again when they are shared.
Okay.
Thank you.
I think this is what is going to happen, because it's a very informative and sometimes difficult for many probably to comprehend. So thank you anyway. So we'll put this on up for everybody to look at it, and then if there are a lot of questions, etc., we might actually invite you back sometimes early next year, or when we'll have a little bit better idea how we proceeded with all these things, and especially in the transport sector. I think last time when you came, you were also talking about how you're going to, or what sort of research you're doing so that the signals are transmitted through tunnels where the signal is weak, how to transmit all this data from one end to the other one without much difficulty, something like that. So there are opportunities for a lot of projects that can happen. As I said in the beginning, the Vice Chancellor is actually holding a special engagement, and he's trying to explain what the financial situation of the university is, what are the consequences, etc. So people are probably in that meeting at this moment. So hopefully they will also look at your presentation at some point. So is there further questions? Yeah, did you want to say anything, Prof. Ansgar?
Yeah, just thank you for inviting me. I'm pleased and honored, and I did never forget. I often remember the beautiful short days in Johannesburg last year, and I hope that we can repeat it as soon as possible. And I'm just I triggered a few student projects now in this field, and I'm happy to share the results with you.
Oh, thank you very much. And through you, let me also pass on our best wishes to Professor Susan Wilper. She made another very excellent presentation last time, and now we'll be waiting for another presentation from Professor Schwartz. Now, all of you who are here, I hope you will attend that as well, because that is going to be another very exciting presentation, all related to how a German university is coping during this pandemic, and they're sharing their thoughts and ideas, etc. with us. We are very grateful for that. I hope we can take a lot of lesson from that particular one. And then let me, on behalf of everybody, thank you again very much for taking the trouble to prepare this presentation. And now I'll just hand over to Precious to say a few things and close the meeting. Thank you.
Thank you.
Thank you, Prof. I think you covered everything. Thank you to all our guests for attending. We meet again on the 15th for another webinar. But in relation to this series, the next webinar is on the 26th of October. Thank you all.
Okay, thank you, Precious, for the nice.
Before we go, 26th, I think in Germany, there is going to be a time sort of difference from 25th. So what we will do, Precious, we'll keep our Johannesburg time the same and probably give the trouble to Professor Peter Orts to link it up. Otherwise, there will be a mix-up in this part, so that we stick to our timetable. And if you don't mind, I'll send another email to Prof. Peter Orts that the time would be this Johannesburg time, 10 o'clock. Again, thank you very much indeed.
Okay, bye-bye.
Bye.
Bye.